Now let us see about computation of DFT and DTFT and also the computation of DFT by using the FFT algorithms. Now we can see, let us see about the computation of DFT and DTFT. Here, while we are seeing the discrete Fourier transform, it converts a finite sequence of equally spaced samples of a function into a same length sequence of equally spaced samples of the discrete time Fourier transform, which is a complex valued function of frequency. And here the DFT is said to be frequency domain representation of the original input signals. And while we are seeing for this DFT, the DFT is defined as, that is the DFT of x of n equal to x of k equal to summation n equal to 0 to n minus 1 x of n in e power minus j 2 pi nk divided by capital N, where k varies from 0 to n minus 1. And also while we are saying this IDFT, the IDFT of x of k equal to x of n equal to 1 by n summation k equal to 0 to n minus 1 x of k into e power j 2 pi nk by capital N, where the small n varies from 0 to n minus 1. Both are said to be the DFT pairs. Now while we are seeing the computation of DFT using the FFT algorithm, the FFT is a highly efficient procedure for computing the DFT of the final series, and also it requires less number of computations that they of direct evaluation of DFT. And that we already have seen that the DFT transform pairs can be represented by using x of k and x of n, that is the DFT of x of n and IDFT of x of k, where here these two equations are represented by using the total factor, that is the total factor is represented as Wn equal to e power minus j 2 pi into n. Now what's the need of going for this FFT? In the case of DFT, we can evaluate only n point DFTs, but in the case of FFT, we can evaluate n point DFT. And also DFT, it requires n into n plus 1 complex additions and n square complex multiplication. In the case of FFT, it requires n log 2 base 2n complex additions and n by 2 log base 2n complex multiplications. Now we want to know what is meant by radix to FFT, or what is the use of this radix to FFT. Here it is the number of output points n can be expressed as a power of 2, that is n equal to 2 power m, that is m is the integer, and this algorithm is known as the radix to FFT algorithm. And here while we are seeing the advantages of FFT over DFT, the FFT is the algorithm used to compute DFT fast and also computationally efficient than direct computation of DFT, and it also exploits periodicity and symmetric properties of DFT, and also it makes use of the periodicity and symmetric properties of the total factor to reduce the DFT computation time. Next we can see about the radix to DIT-FFT algorithm. While we are seeing this FFT algorithm, it is broadly classified into two types, that is radix to DIT algorithm or decimation in time algorithm, and second one is radix to DIF algorithm or decimation in frequency algorithm. While we are seeing in the first case, there is the DIT-FFT algorithm. It consists of n point DFT of the sequence x of n that converts the time domain n point sequence x of n to a frequency domain n point sequence x of k. In this, the DFT, the x of n is decimated and smaller points of DFTs are performed. Also, the results of smaller points DFT are combined to get the results of n point DFTs. Here the n point DFTs can be realized from two number of n by 2 point DFTs, and n by 2 point DFT can be realized from two number of n by 4 point DFT, and so on. Now while we are seeing this radix to DIT-FFT algorithm, the inputs, that is the inputs are given in the bit reversal order. That is nothing but, while for example while we are taking the 0, not 0 1, the binary representation of 1 is 0 0 1, and here bit reversal order we are just writing the LSB bit first, that is 1 next LSB 0 and next MSB 0. Therefore, the bit reversal order of 1 is 4. Similarly, we want to perform up to 7. And here, while we are going for this the radix to DIT FFT algorithm, this is the block diagram. The input that is it is divided into 2, that is even number of sequence and odd number of sequence. And here first it is computed by using 2-point DFT, next it is computed by using 4-point DFT, and finally it is computed by using 4 DFT to get this 8-point DFT. And here, while we are seeing the butterfly diagram of 8-point radix to DIT algorithm, here this is the butterfly diagram. First, that is the 2-point, next 4-point and 8-point. And also, here we want to remember one thing in mind, that is the input or bit reversal order, and here the output are in the normal order. And also the input, that is the upward arrow mark is calculated by using a plus w n power r into b formula, and the downward arrow marks is calculated by using a minus w n power r into b. Here, how we are going to calculate the values of the Tudor factor that is placed in this Tudor butterfly diagram. That is, Tudor factor, we all know that Wn can be represented as e power minus j2 pi by n, and here the Tudor factor is Wn power k, therefore equal to e power minus j2 pi k divided by n. Okay. Therefore, here we are just substituting all the values, and by using the radian mode we are calculating the values for the Tudor factor, and we are just representing the values in the diagram. Okay, that's about the DIT FFT algorithm. And next, the second one is radix to DIF FFT algorithm. In the case of DIF FFT algorithm, the frequency domain sequence, that is x of k, is decimated, and in this algorithm the n-point time domain sequence is converted into 2 number of n by 2 point sequence, and then each n by 2 point sequences is converted into 2 number of n by 4 point sequences, and this process is continued until n by 2 number of 2 point sequence is obtained. And here, while we are seeing the input, here the input is in the normal order and the output is in the bit reversal order in the case of DIF FFT algorithm. And this is the diagram for this butterfly diagram for 8-point radix to DIF FFT algorithm. Here, first one is 8-point, next this is just reverse of DIT algorithm, 8-point, 4-point and 2-point, and here the only difference is, here this is just reverse of DIT algorithm, and also in the case of DIT algorithm the input is in the bit reversal order and the output is the normal order, just reverse of this is D in the case of DIF algorithm. Here we are just replacing all this, that is all the Tudor factor as are denoted in this diagram, that is the radix to DIF FFT algorithm. Now we can see the difference between the DIT and DIF FFT algorithm. While we are seeing this DIT FFT algorithm, it is the time domain sequence and it is decimated, but in the case of DIF FFT algorithm, the frequency domain sequence is decimated. And the second point in the case of DIT FFT algorithm is the input should be in the bit reversal order and output should be in the normal order. Already we have seen this, and in the case of DIF algorithm, the input should be in the normal order and the output should be in the bit reversal order. And also in the case of DIT FFT algorithm, it requires complex multiplication that takes place between the add subtract operation. In the case of DIF algorithm, complex multiplication takes place after the add subtract operation. That's about the difference between the DIT and DIF algorithm, and also the computation of DFT and DTFT by using the FFT algorithm. Thank you.